Hello viewers, continuing with this program and a series of programs in the mathematics for class 12, we are now into the fifth program on determinants and matrices. Remember, in the last program we had introduced you to the concept of determinant and we had given you the idea as to how to evaluate a given determinant. Let us quickly review this idea before we go on to the properties of the determinants. So, let us take a determinant of order 2 and see how we found the value of this determinant. This is the determinant order 2 and when we expanded this, we multiplied these two elements, subtracted the product of these two elements and got the value. In a determinant of order 3, we went on to expand like this, that is, we used the elements of first row 2, 4, 5 and this is how we found the value. And now, every time we got this determinant of order 2 along with the elements of the first row, we ultimately could find the value of this determinant. Now, talking in general, when we write a determinant of the order 3, then this is one of such determinants, and if we want to expand this or want to find the value of this, what we do is we take the element first row first column and then with this we write down this determinant of order 2. This is B 2, C 2, and remember, even there we had given you the idea that you have got to leave this column and this row where this element is coming. Then B 1, leave this column and leave this row. Leaving this row and leaving this column, we are left with A 2 C 2, A 3 C 3. So, A 2 C 2, A 3 C 3. And what was for C 1? We wrote down C 1 into, leave this column and leave this row, and the remaining determinant of order 2 is A 2, B 2, A 3, B 3. Now, these determinants that we are getting from this main determinant with respect to the elements of this row are known as the minors of these elements. With respect to these elements, we are getting this, this and this as 3 respective minors. These minors, remember last time we told you, become the cofactors the moment along with the minor we consider the sign. That is, in case I say this is a positive sign with this, then this becomes the minor as a cofactor, and if this minus sign is considered with this, this becomes a cofactor. The minor of B 1 then is written as the cofactor. That is, the minor and the cofactors in case of determinants are differing only, that is, in case we consider the element of any determinant, the row or column of a determinant, then the balance determinant, that is of the reduced order. In that case, the moment you write the determinant without bothering about the sign, then it is a minor, but in case we attach the proper sign with it, it becomes the cofactor. Let us take another look. Say this is 3, 4, 1, 2, 1, 0. This is 1, 2, 3. What will be the minor of 4? Minor of 4, leave this column and leave this row. This is 2, 0 and 1, 3. This is the minor for this element. When will this become the cofactor? It will become the cofactor the moment we are attaching the proper sign to this. Now, how that sign can be determined? It is very simple. We now give you a very important idea, that is how you can determine the sign to be attached to a minor, so that the given determinant of order 3 can be, or for that matter any order can be determined. So, let us take another look at this determinant 3 4 1 2 1 0 1 2 3. If I am expanding with this column in the row 1, we have already seen what happens, but in case I choose to expand it by any other row or by any column, then I must be very careful about the sign I am attaching to the cofactor. We give you a very simple way of finding the sign. See, with 3 we wrote down the positive sign. 3 belongs to the first row and first column, and if you take this 1 and 1, this is an even number. This 4 belongs to the second column and the first row. 1 and 2 is 3 odd number, and 1 when we were expanding with the first row, 1 is belonging to row 1 and column 3. This 1 and 3 is 4, that is an even number. This might be giving you straightway an idea as to how to write the sign for the given minor to make it a cofactor. Say for instance, we are writing the cofactor for 2. Now, this 2 belongs to which row? Second row. This belongs to which column? Column 1. What is this 2 and 1? 2 and 1 makes 3. This is an odd number. So, that means in case I am writing the minor for 2 and want to change it to a cofactor, then I must attach a negative sign, and this applies to all the elements anywhere. Say this element, this is belonging to the third row, third column, 3 plus 3 is 6. So, the cofactor will be positive 0. This is belonging to the second row, the third column, 2 plus 3 is 5, odd number. So, the cofactor will be negative. I hope this has given you a very simple way of determining as to what sign to be attached to the given minor to make it a cofactor. Now, this gives us an idea that last time when we posed you the question that we have expanded the given determinant using the first row, it can be determined, the value that can be determined by using any row or any column. So, let us go back to the determinant that we expanded last time, and what was that determinant? Let us have a look at that one. That determinant was 2 4 5 1 0 3 6 2 1, and when we expanded this, then we found that using the first row it was 2 into 0 3 2 1 and minus 4 into 1 3 6 1 and 5 1 0 6 2, and this gave us the value as you can see 2 times minus 6 minus 4 times 1 minus 18 plus 5 times 2, and ultimate value comes out to be 66. Let us take the same determinant again. Now, remember the value that on expansion with the first row we got 66. Now, this time I am going to expand this, say using any other row or column. For convenience we take the second row. So, I have got to, when I am expanding this, write down 1. What sign? Simple, second row, first column, 2 plus 1 is 3. So, the sign is negative. Neglect this row, this column, this is the cofactor. Next is 0. Should it be plus or minus? Again second row, second column, 2 plus 2 even. So, plus, this is this row to be neglected and this column to go, and this gives you 2 5 6 1. Then next 3. What sign? This is second row, third column, 2 plus 3 5, odd number, negative. And what is the cofactor? Forget this column, forget this row, 2 4 6 2. What is the value? Minus 1, 4 times 1 is 4, minus 2 times 5, that is 10, 4 minus 10 is 4, 2 5 10, and 4 minus 10 is minus 6. This is 0, answer is going to be 0, but all the same if you feel like you can say this is 2 times 1 is 2, 6 times 5 is 30. So, that is minus 28, 3, 2 2s are 4, 6 2s are 24, 4 minus 24 which is minus 20. This gives you 6 plus 0 plus 60, that is 66. And what was the value that you got when you expanded it with the first row? Same 66. And you may like to try it by expanding any given determinant first by using the first row, then first column, second row, second column, or for that matter any row or any column. Remember, this does not apply only to a determinant of order 3, it applies to determinants of all orders, but mainly we are dealing here with order 3, which is within the purview of your syllabus for class 12. Okay. Now, having talked about this, having understood what the minor is, what the cofactor is, we are now into the main part of our program, that is we want to give you certain properties of these determinants. What are these properties? We start with the first property, that is in case we take a determinant say 2 1 3 4 5 2 0 3 4 and we interchange the rows and columns. What I did was that this is 2 1 3, the first row becomes first column, second row becomes second column, third row becomes third column. What will be the value of this determinant? Value of this determinant, use any row or any column to expand. For convenience we start with say 2 on the first row. So, 2 times this and this gone, 5 4s are 20, minus 3 times 2 6, 20 minus 6 is 14. So, I put on 14 minus 1 into this gone, 4 2 0 4, 4 2 0 4. So, 4 4s are 16 minus 0. So, I get 16 and plus 3 times what will I get? See, this is 3, this column neglected and leave this column this row 4 5 0 3, 4th is a 12 minus 0. So, this is 12. This gives me 28 minus 16 plus 36, this comes to 48. Now, let us try the same thing with this change determinant. If we once again expand it by using the first row 2 into 5 4s are 20 minus 6, 20 minus 6 is 14 minus 4, this gone, 1 4s are 4 minus 9, 4 minus 9 is minus 5 and then 0, because no matter what comes in between this is going to be 0. So, we may not even bother to write what it is in this. So, what do I get? 2 4 14s are 28 and plus 20, this is 48. You may like to experiment this by taking some more determinants, and every time you will discover that soon as you interchange the rows and columns of the given determinant, the value of the determinant does not change. This is the first major property. Let us from here on go on to the second property. Here we are taking mutual change of 2 rows or columns. Say this is the determinant 3 1 2 0 2 4 2 1 1. We have interchanged the first row and the third row to write this new determinant 2 1 1 3 1 2. Let us try the same thing out to find the value of this. Expanding by the first row 2 1s are 2 minus 4, that is minus 2 minus 1 into, when you leave this and leave this 0 1 0 minus 8. So, this is minus 8 and then plus 2, 0 1s are 0, 2 4s are 4. So, minus 4. This gives me the value minus 6 plus 8 and minus 8, which is minus 6. Let us see what happens to this. expanding by again by the first row, this is 2 into this is the determinant 2 2s are 4 minus 4 which is 0 minus 1 this gone 0 2s are 0 3 4s are 12. So, minus 12 and then 1 what will be the value 0 minus 6 this gives me 0 plus 12 minus 6 which is 6. Look at these two values, one is minus 6, the other is plus 6. You see that the numerical value stays the same, but they become opposite in sign, and this you can experiment by interchanging any two rows and any two columns of any determinant, and you will always find that this is what you will discover, that interchange of any two rows or any two columns changes the sign of the value of the determinant, the numerical value stays the same. Let us go on to the next property now. Here we are taking up the effect of multiplying a row or a column with a scalar. We took this determinant 2 1 0 3 4 2 5 0 3 and multiplied just any row at random or any column we can do that. I multiplied this 3 4 2 with a is a scalar, remember, and in case we find the value of this gives me 2 4 3s are 12 minus 0 this is 12 minus 1 this is the determinant 3 2 5 3. So, 3 3s are 9 minus 10 which is minus 1 and then 0. I may not write anything because ultimately when I am multiplying with 0. So, the answer is going to be 0, but still if you want to these 3 zeros are 0 minus 20. So, it is going to be minus 20. The value is 24 plus 1 which is 25. Let us look at this. This is 2 4 a 2 a 0 3. So, 4 a multiplied with 3 this is 12 a 0. So, nothing comes minus 1 times this is here 3 a times 3 9 a minus 2 a times 5 10 a 9 a minus 10 a. So, minus a and same thing here 0 times anything does not matter, we do not write this because this is going to be 0. This gives us 24 a plus a which is 25 a. Look at the two values. When we multiply just one row or for that matter one column of any determinant by a scalar, the value of the entire determinant gets multiplied by the same scalar. Well, this takes us on to the next property, that is when we have a determinant of a special kind. And what is that? We may have a determinant which has got identical rows, two identical rows or two identical columns. I have taken columns here and with the rows we can experiment. But let us first look at this particular determinant which has got the first column and the second column identical. If I expand this determinant, I will be getting a c d e f minus a c d e f and plus b c c e e. What do you see here? A C D E F, A C D E F subtraction, this is going to give you 0. We do not have to bother to find the value or to work it out, because we find that this is the same value subtracted the same value, and what of this C E minus C E, what are you going to get? C E minus C E or E C, this is the same thing 0. So, that means the answer here is coming out to be 0. Once again, this A multiplied with C, D, E, F, this is the determinant, C, D, E, F identical determinant, same value, A the same number multiplying. So, these two values are equal. When these two values are equal, you are subtracting, you get 0, and this is C E minus C E, this is also 0. Let us try the same thing by having a determinant where we have got, instead of two identical columns, two identical rows. Look at this one. We have it here that A B C is the first row, D E F A B C. These two rows are identical, and you can see the expansion is written. Now, here the decision that we could make is not that simple, because when we expanded by the columns, then we found that the determinants of this kind, they came out to be equal, but does not matter. Let us expand this. When we expand this, we get this A into this E C minus B F, and then B, the value here, and this value here. And further, when you expand, you will find that the values intercross, and once again the answer that you are getting is 0. Having seen these properties, before we go on to the next property, we want to once again recollect the two properties that we have already done. What were those? The first one about the identical rows, that is two rows or columns. This was the first one, and the second one where we had the determinant value getting multiplied by a scalar, when we just multiplied one row of the determinant by a scalar. Now, in case we have another look, we find another determinant where the two rows may not be exactly identical, but there is another sort of relation between the two. I write a determinant of that sort. See, this is the determinant, say delta, which is 2, 3, 4, and this is 1, 0, 2, and now this is 2 A, 3 A, 4 A. What do you think will be the value of this determinant? See, this third row is a scalar multiple of the first row. This scalar multiple is going to give us the entire determinant value just getting multiplied with this scalar A, but otherwise this 2, 3, 4, this 2, 3, 4 are the same. So, in case you expand this determinant, what are you going to land up with? This is 2, 0 times 4 A minus 2 times 3 A, which is minus 6 A. This is what the first factor comes out, 3 times 1, 2, 2 A and 4 A, 4 A minus 4 A, which is 0, and then plus 4 into what? 1 times 3 is 0, sorry 3 A, and 2 times 2 A times 0 is 0, which comes out to be 3 A. 4 into 3 A, 12 A, 2 into minus 6 A, minus 12 A, minus 12 A, plus 12 A. This determinant is once again having the value 0. So, we arrive at yet another property. The rows may not be exactly identical if one row is a scalar multiple of another row, or for that matter a column is a scalar multiple of another column, then even then the value of the determinant is going to be 0. Here we go on to the next property, that in case we add or subtract the scalar multiple of a row, or for that matter a column, to another row or subtract it from another column. Say this is it, 2, 1, 0, 1, 2, 3, 4, 3, 5 is a determinant. What I do is, double of this, that is I take 2 times 2, 2 times 1, that is scalar that I am using is 2. I subtract that from this third row. Let us see what I get. The new determinant, this is a question mark whether they are going to be of the same value. The determinant that I get is 2 1 0 and 1 2 3, double of this subtracting from this, 2 2s are 4, 4 minus 4 is 0, 2 1s are 2, from 3 we subtract, this is 1 0. So, this will remain 5. Now, let us look at the value of this determinant and the value of this determinant. This is 2 into 2 5s are 10 minus 9, which is 1. 1 into 1 3 4 5. So, 5 minus 12, which is minus 7. 0. So, no matter what comes up, this is going to give you 0. So, the value comes out to be is 2 plus 7, which is 9. What of this? This gives you 2, 2 5s are 10 minus 3, which is 7, minus 1, 1 3 0 5, 1 5s are 5 minus 0. So, I get 5, and then this is what, plus 0, no matter what is being written. This gives me what, 2 4 7 7s are 14 minus 5, which is 9. We see that the value is once again the same. So, in case the scalar multiple of one row was subtracted from this from another row, then the value did not change. The same thing will apply in case you experiment, that in case the scalar multiple is added to another row or scalar multiple of one column is added to another column. Now, for that matter, now we go on to the last property, whereby we want to show you that in case one of the rows or elements of a row or a column can be written as the sum of some scalars, then there is a relation resulting in the value of the determinant and the two resultant determinants. Look at this. In case we look at this determinant, we find that by ordinary expansion, this is the value that we reach at. We will be showing you this one once again, but what we are more interested in is that how can this determinant be written as a combination of two determinants. Let us have another look at this. This determinant can be written as A C E drawn from here, these same, B D F drawn from here, and these as here. Now, in case you care to expand this and expand this, you find that the value of the determinant will be A into 5 times 1 and minus 6 times 2 12. So, 5 minus 12 minus 7, and then minus 3 C minus 6 A. So, I will have to write my C minus 6 A, and then 4 2 C minus 5 E. This is the value I get from here. When I expand this, I get B 5 minus 12, that is minus 7, minus 3 D minus 6 A 6 F, and 4 2 D minus 5 F. Now, in case you combine these values and look at the value of the determinant that we get by ordinary expansion, you will find that the two values come out to be the same. We may not be able to give you more examples in this particular program, but we will be reviewing this property once again before we start applying these properties in our next program. But till then, you are advised to review these properties and go over them once again. Thank you.